is the standard unit of measurement of the quantity of a chemical substance in chemistry. 1 mole, or it's abbreviated as just MOL, is equal to 6.022 times 10 to the 23rd atoms. So it's a unit for counting a quantity of atoms. And this may seem like an arbitrary number. This number comes from, again, carbon-12. And they got this number by finding how many atoms is in 12 grams of carbon-12. And the reason they picked 12 grams of carbon-12 will become apparent in a second. It will make a lot of sense. So they found that in 12 grams of carbon-12, there are 6.022 times 10 to the 23rd atoms. That's where this number comes from. Now, why they picked 12 grams will now become apparent. Because the one thing we do know about carbon-12 from the previous section is that they assigned it a mass, an atomic mass unit of 12. So 1 atom of carbon-12 has an atomic mass unit of 12. And all of the other elements' masses are based off of carbon-12. They're all ratios of carbon-12, which is based on 12 atomic units. Now what this is going to allow scientists to do, or is what it allowed them to do, is to link atomic mass units and grams, and essentially link atoms in grams by doing that. What they did, since 12 grams is equal to 6.022 times 10 to the 23rd atoms. And we know that 1 atom, and this is all carbon-12 by the way, I should mention this, carbon-12, carbon-12. Since 12 grams of carbon-12 is equal to 6.022 times 10 to the 23rd atoms of carbon-12, and 1 atom of carbon-12 is equal to 12 atomic mass units, it can be said that 12 grams, and I'm not going to write carbon-12 now, is equal to 6.022 times 10 to the 23rd times these atoms, but they're going to cancel. And now I want to link their masses. So this many atoms, I'm going to multiply it times the atomic mass unit. "12 grams of carbon has 6.022 times 10 to the 23rd atoms. Each atom is 12 atomic mass units. The atoms cancel. And I'm left with 12 grams is equal to 6.022 times 10 to the 23rd times 12 atomic mass units. Or this can be thought of as 12 grams is equal to 12 times 6.022 times 10 to the 23rd AMUs. Now, the reason why 12 was chosen is apparent, because these 12s are just going to cancel out and just leave an easy conversion that 1 gram is equal to 6.022 times 10 to the 23rd atomic mass units. So now there is a direct correlation, or there's a relationship between grams and atomic mass units. And what this is going to do is allow me to think of these numbers and the elements, like 1.01 for hydrogen, which ordinarily I would have thought as that is the atomic mass units of one atom of hydrogen, 1.01. Now what I'm going to be able to think of it as is its molar mass, the grams per mole of an element. So let me do an example. Let me take oxygen. Oxygen has an atomic mass unit, or in atomic mass units, one atom of oxygen is 15.99. So now what I'm able to do is convert from atomic mass units to grams per atom. What this relationship is going to allow me to do is create a link between quantity of atoms and grams. And the standardized quantity is going to be the mole, which is, again, 6.022 times 10 to the 23rd atoms. So if I take 1 mole of oxygen at an atomic mass of 15.99, how am I going to get grams out of that? Well, I'm going to take 1 mole of oxygen, which is 6.022 times 10 to the 23rd atoms. Each atom having a mass of 15.99 atomic mass units per atom. This is going to give me 15.99 times, and I'm not going to multiply these together, and it will become apparent why. 6.022 times 10 to the 23rd atomic mass units. Now this relationship says that 1 gram is equal to 6.022 times 10 to the 23rd atomic mass units. So essentially I can replace this with this, 1 gram. It's basically going to be 16.022 times 10 to the 23rd, 10 to the 23rd, which is 1 gram. So essentially it's 15.99 times 1 gram. Which is equal to 15.99 grams. And this is going to happen for every element. This 6.02 times 10 to the 23rd will just convert to 1 gram because we chose 12 grams. And that's why 12 was chosen, because it easily interconverts without having to do any extra multiplication or addition. I could do this for any element. I could do this for uranium, plutonium, americanium, berkelium, all of them. And I would get the same situation where I would have, for uranium, I'd have 238 atomic mass units. Is that, yeah, 238.03 atomic mass units per atom. And if I were to take a mole of that, that would be 6.022 times 10 to the 23rd atoms times 238.03 atomic mass units per atom. I would distribute, I'd have this many 10 to the 23rd atomic mass units times 238. This would turn into grams, and I'd have 238 grams. And this is per mole. So now I have a new unit of measurement. These numbers from now on throughout chemistry are going to be called the molar mass. And what the molar mass is grams per mole. So for carbon, or let's take neon, which has 20.18. That means if I have a mole of neon atoms, they're going to have a mass of 20.18 grams. If I have a mole of lead, that is going to have a mass of 207.2. I don't know why I said 20. It's late. Or calcium. If I had a mole of calcium atoms, they would have a mass of 40.08. And that makes sense because calcium has greater mass than something like carbon. Carbon only has 6 protons. Calcium has 20 protons. And this is how stoichiometry and chemistry is going to be from now on. It's going to be dealing with moles and molar mass. And I guess let me do one quick example, just to show how something like this might be used in some kind of other way. Suppose I have 10 grams of aluminum, and I want to know how many atoms there are. I'm going to use my new molar mass that I just learned about. Figure out how many grams are in a mole, figure out how many moles I have, and then convert moles to atoms. So I'm going to go look at my periodic table and look up the molar mass. Aluminum is right here. It has a molar mass of 26.98 grams. That means that for every 26.98 grams, there is 1 mole. 26.98 grams gives 1 mole of aluminum. So I do this, pick up my calculator, and I have 0.371 moles of aluminum. Now I don't want moles, I want atoms. But I know that 1 mole, I'll write it over up here a little more, is equal to 6.022 times 10 to the 23rd. So now I can convert moles, this is atoms, now I can convert moles to atoms. 1 mole is equal to 6.022 times 10 to the 23rd atoms. And that is equal to 2.23. Let me see, 3 significant digits, times 10 to the 23rd atoms of aluminum.